Okay, so the topic for today is arithmetic progression and geometric progression. Uh, Arithmetic AP over here simply means an arithmetic sequence. So we are going to be dealing with arithmetic sequence first. So let's try to understand what is the meaning of a sequence or a progression. A sequence or a progression is a set of terms which are written in a definite order that follow a certain pattern. Example 1, 3, 5, 7, 9. So you can predict the next term, that is going to be 11. So because these terms, Walaikum Salam. So because these terms have a sequence that they follow a certain pattern, you can predict the next term. Okay. So the difference is of a 2, so it's a sequence of odd numbers. Consider the sequence 1, 4, 9, 16, 25. So it's a sequence of squared numbers, so you can predict that the next square number is going to be 36. Then 1, 1, 2, 3, 5, that is a Fibonacci sequence. Fibonacci sequence is a sequence in which the previous two terms add up to give you the next term. 1 plus 2 gives you 3. 3 plus 2 gives you 5. 5 plus 3 will give you 8. So that is a sequence. These are some of the examples of a sequence. And each number in the sequence is called the term of the sequence. Now, a series is basically the sum of this sequence. If you add all the terms, if you write this sequence in this order, 1 plus 3 plus 5 plus 7 plus 9, this is going to be called a series. Series is just the sum of the terms of the sequence. Now, a series is finite if it stops after finite number of terms, and a series is infinite when it continues indefinitely. So if I say that the series is 1 plus 3 plus 5 plus 7 plus 9, okay, then obviously the sum is going to be the finite. And if I write it as 1 plus 3 plus 5 plus 7 plus 9 plus dot dot dot, that means it's an infinite series, so it is going to have an infinite sum. So it's pretty basic. Okay, now let's dive into the topic of today, that is the arithmetic sequence. Guys, arithmetic sequence is a linear sequence in which there is going to be a common difference. Consider this example. The first term is 5, the next term is 8, 11, 14, 17. So that is a series. It's a special series that has a common difference between the consecutive terms. What is the difference between the first two terms? The difference is taken out by taking the second term, second term minus the first term. So what is the difference going to be?
3.
Plus 3, then plus 3, then plus 3, then plus 3. So this is a sequence that has a common difference. It is basically a linear sequence, a sequence that has a common difference where each term differs from the next term by a it's a constant. Okay, the difference is constant, so that is called a linear sequence. The linear sequence is called the arithmetic sequence. All right, so if the first term is 5, next term 8, 11, 14 and 17, you guys know the difference now, it's plus 3. So if the first term is 5, would you agree that you have to add 3 to get the next term? That is 8. Then you add 2 times 3 to get 11. Then the next term is going to be 5 times 5 plus 3 times 3. Then the next term is going to be 5 plus 4 times 3. Okay.
Yeah.
So if the first term is A, term 1 is A, term 2 is going to be A plus D. You add the difference. Then the next term, to get to the next term, you are going to add another difference. So it's going to be A plus 2D. Then you add another difference. It's going to be A plus 3D. Then you add another difference. it's going to be a plus 4d, and so on. So we are going to deduce the nth term of the arithmetic sequence. And if now consider this, when n value was 1, the term was a. When n value was 2, the term is a plus 1d. When the term value is 3, the when n value is 3, the term is a plus 2d. When n value is 4, the term is a plus 3d. When n value is 5, the term is a plus 4d. So would you agree that any general term of this sequence, any nth term, term n of this sequence is simply going to be a plus 1 less than the nth term, so n minus 1 times d. Okay, when the n value was 5, you were adding a plus 4d. So this value is 1 less than the term. So what is T6 going to be? What is the sixth term going to be, guys? A plus
5D.
5d. T7 is going to be a plus 6d. So can I say that in an arithmetic sequence, the nth term is given by a plus n minus 1 times d?
Yeah.
That's the general formula which you need to remember. A plus n minus 1 times d. Okay, where a is the first term, d is the common difference, okay, and L is going to be the last term of the sequence. I'll show you. So if you're asked find the number of terms in the arithmetic progression, so they have already told you that this is arithmetic progression. Well, you can identify as well. What is the common difference over here?
4.
The first term is -3, okay? And the common difference is 1 minus -3, that is 4. Or 5 minus 1, that is 4. 9 minus 5, that is 4. So whenever you have a common difference in a sequence, that is an arithmetic sequence. Is it a finite sequence or is it an infinite sequence?
Finite.
Finite sequence, because you already have the last term of the sequence. Now, the last term occurs at the nth value, the last value, okay? So if I ask you to find how many terms are there, you need to know at what position is this value occurring. Okay, what is the position of this value? So for example, this is the first term, this is the second, third, fourth, fifth, and so on. This is my last term. So if you want to find the number of terms in this arithmetic sequence, you will need to know at what value of n are you going to get the last term as 237. So the nth term in a arithmetic sequence was given by a plus n minus 1 times d. The a is the first term of this sequence, that is -3. D is the common difference of the sequence, that is 4. And if I want to calculate the last value, would you agree that I'll be using the last term over here in place of Tn?
Yes, sir.
So Tn is 237. All right. Come on, solve this and give me the correct value of n. (237 plus 3 divided by 4 plus 1).
61.
61. So this tells me that in this series, in this sequence, there are 61 terms, and the last term is the 61st term, which is 231. In this question, you were asked to find the number of terms. The number of terms are 61. Do you guys get this example?
Yes, sir.
Sir, in under term number, why did you write 237?
Because I'm saying that n is the last term. Okay, and the last term is 237.
Okay.
So when you calculate n comes out to be 61, which means that from the start there were 61 terms. For this term, n value is 1. For this term, n value is 2. n value is 3, n value is 4, n value is 5. Okay, so this is going to be the last term, and using this equation, this is this nth term formula, I was able to calculate that at which position is the last term occurring. So n comes out to be 61, which means that it is the 61st number of the sequence. So in total, there are 61 numbers. Make sense? Everyone, does it make sense?
Yes, sir.
Okay. The fourth term of an arithmetic progression is 7 and the 10th term is 16. Find the first term and the common difference. So the question says that it's an arithmetic progression. Okay, guys, what is the nth term in an arithmetic progression given by? Tn is equals to a plus n minus 1 times d. Remember this formula. So in the question, they have given you that the fourth term, which means T4, is 7. And they have given you that the 10th term is 16. Can you guys tell me what is going to be the fourth term in terms of A and D? If n value is 4, so T4 is going to be equal to A plus
3D.
3D. Good. So that means A plus 3D is my fourth term in an arithmetic sequence. What about the 10th term? A plus
9D.
9D equals to 16. Now you need to calculate the value of the first term and the common difference, which is A and D. You have two equations. You're going to solve them simultaneously. So guys, give me the value of A and D. What's the value of A and D?
D I got 3/2, and for A I got 5/2.
Okay, that's correct. Okay, everyone gets it?
Yes, sir.
All right. Now, guys, try the next one. I'll just wait for the azan to get over. Okay, so the nth term of an arithmetic progression is 5 minus 6n. You don't need to make an arithmetic, you don't need to make the nth term. They have already given it to you. You need to find the first term and the common difference. Okay, so the first term means T1. So in place of n, you're simply going to plug in 1. So what is 5 minus 6? Negative 1. So the first term, T1, or the value of A, is minus 1. Now to get this common difference, I need common difference means the difference between the two consecutive terms. So if I have T1, I need to find T2 now. T2 is going to be 5 minus 6 times 2, that is 5 minus 12. Okay, negative 7. Now T2 is negative 7. So what do you think the difference is going to be between what is going to be the common difference? Common difference is the difference between the consecutive terms. Minus 7 minus 1.
Negative 6.
Negative 6. So common difference is negative 6 and the first term is negative 1. Okay?
I still didn't get
Sorry?
what is it?
Hassan, I'm
What
not
they,
able to hear you. Yeah.
yeah, so I was saying, could you explain what this is again? Because I didn't understand it. Is this the replacement for the A plus n minus 1D?
So
Or
instead of making you use this, they have already used this, okay? and they have simplified this as 5 minus 6n. So they have told you that the expression for the nth term is 5 minus 6n.
Oh,
They have already told you the simplified nth term expression. You just have to use it now.
what is the value for the connector?
I'm sorry?
Never mind. Okay, fine. I got it.
Got it? Okay.
Yeah.
So that was one formula to find the nth term of an arithmetic sequence. You need to remember this formula, a plus n minus 1d. This is only valid for the sequence that is an arithmetic sequence. Please remember the difference. What is so special about the arithmetic sequence? That it has a common difference. Now, the next thing that we are going to learn is the sum of the terms of the sequence. Okay, and I'll be showing you two formulas. The derivation and the proof is not required. When I'll upload the notes, you can just refer to it. I have over here derived the formula for you, but right now I'll just be making use of the two formulas, and I'll explain the two formulas. Sn means the sum of first n terms, which means if I have an arithmetic sequence of 10 numbers, okay, there are 10 terms, S3 would simply means the sum of first three terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. S3 would mean the sum of the first three terms. S4 would mean the sum of the first four terms. S10 would mean the sum of all the 10 terms. So this is what Sn means. Sn means the sum of the first n terms. Now there are two formulas to calculate the sum of the first terms of an arithmetic sequence. In an arithmetic sequence, if the sequence is arithmetic, okay, you can use these two formulas. N represents the number of the terms, okay, till where you need to find the sum. A represents the first term, L represents the last term. Okay, so the formula is n upon 2 times A plus L. That is one formula. The other formula is n upon 2 times 2A plus n minus 1 times D. Okay, that's the next formula. So these are the two formulas that you need to know and you need to make use of them. So the second formula is the most common formula because it is expressed in terms of A and D, the first term and the common difference. If you know an arithmetic sequence whose first term and the last term you know, then you can also use this formula, n upon 2 times A plus L. This is going to give you the sum of the first n terms. It's going to be clear if you use this formula. In an arithmetic progression, the first term is minus 12. That means that A value of an arithmetic progression, it's a AP question. A value is negative 12. And then the question says that the 17th term is 12. Okay. And the last term is 45. Last term is 45. Find the sum of all the terms in the progression. Now, you need to find the sum of all the terms of the progression. Sum of all the terms means Sn. So let there be n values in the arithmetic progression. You need to find Sn. Sn is calculated using two formulas, n upon 2 times A plus L, or Sn is equals to n upon 2 times 2A plus n minus 1 times D. Okay, by reading the question, do you guys know how many terms are there in altogether? Altogether, how many terms are there? Do we know that?
Yes.
No, we don't. We don't know how many terms are there. How many total terms are there? We just know that the
Oh,
first
yeah.
term is 12. We know that the 17th term is 12. And we know that the last term is 45. Can you guys come up with a way of finding the total number of terms in this sequence, given that this
Sir, I'll use Sn.
sorry?
I'll say n over 2 bracket a plus n.
But you know the first term, you know the last term, okay, but you don't know the number of terms. That's the problem. So you
So
can't
you
calculate
the
Sn.
term number formula.
Yes, you can use the term formula, that's correct, but how are you going to use it? The term formula is Tn equals to a plus n minus 1 times d.
Sir, can we take under term 17 a plus 16 d equals to 12?
Very good, that's one way. A plus 16d is going to be equal to 12. That's one equation. What else can we do?
So how did you get a plus 16d is equals to 12?
She said that the 17 term is 12. Since we know that the 17 term is 12, so T17 in an arithmetic progression is going to be equal to a plus 16d, right?
Yeah.
It was a plus n minus 1d, so T17 is going to be a plus 16d. Okay, now do I know the value of a?
Yeah.
Yes, that is negative 12. So will this allow me to calculate the value of d, the common
Yeah.
difference? Okay, so what's the value of d coming out?
1.75.
Isn't it 1.5?
Oh, sorry. Okay.
1.5, 24 divided by 16, 1.5. Okay, so that's the common difference. This is negative 12. Now, what other thing do we need to have to find Sn?
You need to have
N.
the number of terms.
The number of terms. Do I know the number of terms in the entire progression?
No, sir.
No, we don't. How can we find that out?
You plug in into Tn.
Sorry?
You solve for n using Tn equals a plus n minus 1d.
Okay. So if you are going to use this formula Tn equals to a plus n minus 1d, you know a is negative 12, n minus 1, d is 1.5. But what about Tn?
45.
Yes, you're going to use 45 because this is the last term. So the last term, using the last term will get you the value of n, which is going to be the total number of terms. So you're going to use 45 over here. So solve this for n, please. What value of n are you going to get?
39. There is 39 the answer.
Sorry?
39.
39, that's correct. So n value is 39. That means that there are total number of 39 terms. There are total of 39 terms in the progression. And now you need to find the sum of all the terms, which means the sum of 39, which means sum of S39. So
Also
S39,
39 divided by 2.
yes,
A, that is negative 12 and L is 45.
very good. You can use this. Or we could also have used this formula, 39 upon 2 times 2 times a, that is negative 12, plus 39 minus 1, that is 38 times d is 1.5. Sometimes when we don't have the last term, we are always going to go for this formula. Okay. Now, for now, just calculate this. What is the sum of 39 terms?
643.5.
643.5. That's correct. So that is the sum of first 39 terms. I'll do an example by using the other formula as well. So S39 using the other formula, that's going to be 39 upon 2 times 2a plus 30 n minus 1, that is 38 times d. So if you use this formula, you are still going to get the same result. Okay. If you want, you can confirm it. 2 times negative 12 plus 38 times 1.5 times 39 divided by 2, that's 643.5. Okay. All right. Now the next example. Okay, so everyone right now is clear how to make use of
Yeah.
both the formulas. Okay. Now there is another concept that is to find the nth term. Okay, guys, try to understand this. 1, 2, 3, 4, 5, 6, 7, 8. Let's say there are 8 terms of the progression, and I ask you to calculate the 8th term. You can find, in order to find the 8th term, would you agree that you can calculate S7? S7 would mean the sum of the first 7 terms, and you can calculate S8. That means the sum of the first 8 terms. Would you agree that the sum of the first 8 terms minus the sum of the first 7 terms is going to give you the 8th term? Yes or no?
Yeah.
Okay, so please remember this as well, that sometimes the question may be designed in such a way that to find the 8th term, you will have to do calculation S8 minus S7. Okay, if I want to find the 6th term, that is going to be first find the sum of the first 6 term minus the sum of the first 5 terms. That is going to give you the 6th term. Is everyone clear with this logic?
Sir, so the answer would be S only?
No, I'm saying that in order to find the 6th term, you can make use of the concept of sum to find the term as well. So let's say if I want to find this term, the 8th term, I can calculate, if there is a possibility in the question to know the sum of the 7 terms and to know the sum of the 8 terms, I can just take the difference of S8 minus S7 and to get the 8th term. Similarly,
Okay.
the 6th term is going to be S6 minus S5. What about T4?
S4, and that will be minus S3.
Right. Okay, everyone is clear till here? Okay, let's try this example. The 10th term in an arithmetic progression is 14, and the sum of the first 7 terms is 42. Find the first term of the progression and the common difference. The 10th term or in an arithmetic progression is 14. Okay, so T10 is 14, and the sum of the first 7 term is 42, which means S7 is
Subtract them.
42. You need to find the first term and the common difference. So I will have to write down the 10th term, okay, T10 in terms of A and D. Manu, in terms of A and D, what is T10 going to be?
A plus 9D.
Yes, A plus 9D. That is going to be equal to 14. And Hassan, what is S7 going to be in terms of A and D?
Will you repeat? S7.
In terms of A and D,
Oh,
what is
okay.
going to be the
A
expression
plus
for?
A plus 16.
No. I'm talking about the sum now, not the term. So
Oh,
remember the term sum formula was n upon 2, 2a plus n minus 1 times d. That is
yeah,
Sn, okay? So
yeah.
S7 is going to be 7 upon 2, 2a plus 7 minus 1, that is 6d.
Oh,
Make sense?
yes, sir.
So you are going to again make two equations and solve them simultaneously. So if you simplify this equation, this is going to be 7a plus 21d equals to 42. And that's your equation number 1, a plus 9d equals to 14. You're going to solve equation 1 and 2 simultaneously.
Why did you like for S7 you did 7 over 2 use the other formula?
Because that is S7, not T7. When it says S7, the
Okay.
sum of the first 7 terms is 42. So you will have to use the formula for the sum. When it says that the 10th term is 14, so you are going to use the formula for the term.
Okay. Okay, understood, sir. Yeah, sure.
Okay. What's the value of A and D? Okay, I'm getting A as 2 and D as 4 upon 3. Please confirm whether these values are correct or not.
Yes, sir. Same way.
Same values? Okay.
Yeah.
Let's try the next one. The sum of the first n term Sn of a particular arithmetic sequence is given by Sn equals to 4n square plus n. So see, they have already given you the sum formula. So they had derived the sum formula for you, okay? They have already given it to you. Now you don't need to write down the formula again. You are just going to make use of this formula to calculate it. So Sn obviously will give you the sum. If you're going to plug n value, you're going to get the sum value for those n terms. All right. How do I find the first term? If the sum formula is given, how do I find the first term?
So we use n divided by.
No.
So we do S1 equals 4 1 squared plus 1.
Yes.
So
S1, the first term, the sum of the first term is going to be the first term itself. So you are going to plug in
4
n as
1
1.
square plus 1.
Yes, so that is going to be 5. If S1 is 5, would you guys agree that A value is also 5? The first term is 5.
Yeah.
Okay, that is common sense, right? The sum of the first term and the first term is going to be the same. Now, how do I find the common difference between the terms?
you find it for S2 and you find the difference. So the difference would be 13.
Yeah, but first you are right that you are going to find S2. S2 is going to give you the sum of the first two terms.
Yeah.
Okay. S2 is coming out to be 18. That is the sum of the first two terms.
Yeah. And then you
So
subtract.
you are going to first find the second term. How do you find the
18
second term?
minus 5.
Would you
Yeah.
agree T2 is going to be S2 minus S1?
Yeah, that's I think.
18 minus 5, that is 13. Right?
So third term will be 18 plus 18 plus 5. That will give me.
No, sir.
No,
So
the second term is going to be 18 minus 5, 13. Now, the common
13 minus
difference is the
5 is
difference
8.
between the
Difference is
consecutive
13.
terms. The second term is 13.
Sir, D is 8.
Yes, D is the second term minus the first term, that is 8. Okay? So that is how you find the common difference. Everyone is clear with the working? Manur, what about you, Zores? Is the working
Yes.
clear? Zores, is the working clear to you?
Yes, sir.
Okay.
Uh,
Now we need to find the expression for the nth term. Nth term for what sequence? What is the sequence? It's a arithmetic sequence. So what was the nth term for an arithmetic sequence? Equal to Tn was equals to
A
A
multiplied by n minus 1.
A plus n minus 1 times D. A value is 5 and the common difference is 8. So 5 plus 8n minus 8, that's going to be 8n minus 3. So the nth term for this arithmetic sequence is 8n minus 3. Are you clear till here?
Yes, sir. Understood.
Understood? Okay. Can I move on?
Yes, sir.
Okay. Now, guys, the next type of sequence that we are going to study is geometric progression. In geometric progression, the consecutive terms will follow a common ratio. Okay, so if you divide the second term by the first term, what is the ratio?
Sir, what could you repeat?
So in the geometric sequence is a progression in which there is going to be a common ratio. So can you divide the second term by the first term? What do you get?
Yeah, 3.
3.
3.
If you divide the third term by the second term, what do you get?
3.
3.
Fourth term by the second third term?
3.
3. So that means that it is a sequence that has a common ratio. So would you agree that every sequence when multiplied by the common ratio, every previous term when multiplied by the common ratio is going to give you the next term? So 2 times 3, 6.
Yes, sir.
6 times 3, 18. 18 times 3, 54, and so on. So in a sequence where the first term, okay, where n is, where the first term is going to be a, okay. So to get the next term, would you agree that I will have to multiply the common ratio with the first term? So if I
Yes, sir.
denote common ratio as r, would you agree that the second term is going to be a multiplied by r?
Yeah.
That is
Yeah.
ar. Then the third term is going to be when the second term is multiplied by r again. So ar times r is ar square. Now the third term, in order to get the fourth term, you need to multiply the third term by the common ratio again. So what is ar square multiplied by r?
Yeah.
Ar to the power of 3, ar cube. Ar cube multiplied by r, ar to the power of 4, and so on. Now notice this, that the first term is a, the second term is ar to the power of 1. The third term is ar to the power of 2. The fourth term is ar cube. The fifth term is ar to the power of 4. So whatever the value of n is, the power of r is 1 less than that value. Okay. So can I say that the nth term in this sequence is going to be ar to the power of n minus 1? Okay. So that is the general formula for finding the nth term in a geometric progression. Tn means the nth term in a geometric progression is going to be equal to a times r to the power of n minus 1. So guys,
So that
what
would
is,
be AR 5.
so what is T6 is going to be? AR to the power of 6 minus 1, that is 5. What is T8 going to be? The 8th term is going
8
to
to the
be AR to the power
power
of
7.
7. Okay. Everyone is clear till here?
Yes, sir.
Okay, now the fifth term of a geometric sequence is 1. So fifth term of a geometric sequence 1 means T5 of the geometric sequence is 1. And the common ratio is 1 upon 2. The common ratio is denoted as 1 upon 2. Okay, the common ratio is denoted as r, whose value is 1 upon 2. Guys, you need to find the 8th term first. How do I find the 8th term? What do you think the 8th term is going to be equal to in terms of a and r?
AR to the power of 7.
ar to the power of 7. So in order to find the 8th term, if I know the value of a and the value of r, I can use this expression to calculate the 8th term. But do I know the value of a?
No.
No. What is T5 going to be equal to?
AR to the power of
1.
4.
ar to the power of 4, and that is equal to 1. The value of r is 1 upon 2. So use your calculator, do the maths. 1 upon 2 raised to the power of 2, 1 divided by this value. So what's going to be the value of a?
Sir, I'll find the A, then I'll put it into T8.
Yes. 1 upon 2 to the power of 4. 2 to the power of 4 is 16. So a comes out to be 16. That is my first term. Okay. Now,
You
in
multiply
order
by
to find
0.57.
16 times 0.5 to the power of 7. So what is T8 coming out of the ring? Guys, what is 16 times 0.5 to the power of 7?
So the answer is 0.125.
Yeah, which is 1 upon 8. Okay, or 0.125. So the first term is 1 upon 8. Oh, sorry, the 8th term is 1 upon 8. Now the question says find an expression for the nth term. Guys, the nth term in a geometric progression is given by ar to the power of n minus 1. A value is 16. R value is 1 upon 2, simply n minus 1. Okay, that is Tn. Now this expression can further be simplified as 16 can be represented as power of 2. So 16 is 2 to the power of 4. 1 to the power of anything is 1. 2 to the power of n minus 1. Okay. Now when when the bases are same and the numbers are being divided, what happens to the power?
Verse.
Sorry?
And verse.
No, the powers are going to be subtracted. You just have to use the rules of indices to simplify this. It's going to be 2 to the power of 4 times 2 to the power of negative n minus 1. When bases are same and are being multiplied, just add the powers. 4 minus n minus 1. So 2 to the power of 4 minus n plus 1. 2 to the power of 5 minus n. Okay. Or you basically you could have left your answer in this way as well. That's also acceptable. If they particularly ask you to show that the expression simplifies down to this, you can do that. Okay. But for now, let's take the answer in this form. Clear?
Yes, sir.
Okay. The second and the fifth term in a geometric progression are 12 and 40.5 respectively. Find the first term and the common ratio. How do I go about this question? The second and the fifth term of a geometric progression, T2, second term is 12 and the fifth term is 40.5 respectively. You need to find the first term and the common ratio. Is this information sufficient for us to find the first term and the common ratio?
So you don't have A or R.
So yes, T2, would you agree that T2 is going to be AR to the power of 1?
Yes.
And T5 is going to be AR to the power of 4?
Yes.
Okay, I have two equations. I can solve them simultaneously. Okay, so from the first equation, A is going to be 12 upon R. Okay, and you can substitute this value in the second equation. A value is 12 upon R times R to the power of 4 equals to 40.5. So if you simplify this down, what is going to be the power of R? How would you simplify this? R to the power of 4 divided by R to the power of 1 is?
Uh,
Three.
R to the power of 3. Okay. Then R cube is going to be 40.5 upon 12. And then simply you can take the cube root. So what do you guys get?
1.5.
Cube root of this?
1.5.
Yeah, 1.5. Okay, that's the value of R. If you know the value of R now, can you give me the value of A? A is 12 divided by 3 upon 2, which comes out to be
8.
8. Okay. So for this geometric progression, we have the first term and the common ratio. Can we now come up with the nth term expression? AR to the power of
Yeah,
n
we-
minus 1. The first term is 8. The common ratio is 3 upon 2 to the power of n minus 1. Okay. You can leave your answer over here.
Okay.
I don't need to simplify it like in the last slide, did I?
No, don't simplify until they specifically ask you to do so. Okay.
Please simplify this one, sir, just in case.
All right. So if you are asked to simplify this, So it's going to be 3 to the power of n minus 1 divided by 2 to the power of n minus 1. 8 can be represented as 2 to the power of 3. So when bases are same, these bases are same, so the powers are going and are being divided, so the powers are going to be subtracted. So 3 minus n plus 1 times 3 to the power of n minus 1. So 2 to the power of 2 minus n times 3 to the power of n minus n. Okay, but you are not supposed to do this kind of simplification until unless they tell you to do so. Okay, I have checked the marking scheme, and if you also check, they do give you marks if you leave the answer till this step. Are we clear?
Yes, sir, sure.
Okay. The nth term of a geometric progression is 9 times minus 2 upon 3 to the power of n. Find the first term and the common ratio. Okay, how do I go about this question?
They have given you the final answer this time.
They have given me the nth term, that is 9 times minus 2 upon 3 to the power of n.
So I can say that A is 9,
Let's find out.
R is negative 2 over 3.
The first term is going to be 9 times minus 2 upon 3 to the power of 1. Okay, you are going to replace n as 1 for the first term and simplify this. So that's going to be minus 6, right?
Yes, sir, yeah, that's negative 6.
Okay. Now, in order to find the common ratio, do you guys agree that I need the second term?
Yes,
Yeah.
sir, so it's n minus 1.
So, no, the second term T2 using this formula is simply going to be 9 times minus 2 upon 3 to the power of 2. So that's going to be 9 times 4 upon 9. So the second
4,
term
the
comes
answer
out to
is
be
4.
4. Now, what is the common ratio? Common ratio means the ratio of the consecutive terms. So
Okay.
that is going to be T2 upon T1, that is 4 upon negative 6, that is negative 2 upon 3.
Is that a coincidence or is
No,
it
it's
like
not.
always?
Like, why do you say it's a coincidence? Like, what makes you say that?
Like the value they give you like 9 times minus 2
Yeah.
over 3 is the same as the
No,
common ratio.
it's not a coincidence. That is always going to be the case. The reason being, so, okay, if I do the reverse working, let's say I know that the first term is minus 6 and the common ratio is minus 2 upon 3. If I ask you to find the nth term, would you agree that you're going to use a times r to the power of n minus 1? So the first term is minus 6. The common ratio is minus 2 upon 3 to the power of n minus 1, right? Now, you can see that this is not the same as this. You will have to simplify it further. Minus 6 times minus 2 upon 3, okay, to the power of n divided by minus 2 upon 3. Would you agree with this? The power was n minus 1.
Did you divide?
So the power was n
Okay.
minus 1. So I'm splitting the terms so that when they are simplified, the power of minus 2 upon 3 is going to be n minus 1. Now just calculate the value using your calculator for this. Minus 6 divided by minus 2 upon 3. What do you get?
4.
No.
6 multiply. Oh, divide, you mean? Okay.
Divide. Minus 6 divided by minus 2 upon 3.
9.
9. So there is 9. So Tn is going to be 9 times minus 2 upon 3 to the power of n. Okay.
Okay.
Over here, the value of r is minus 2 upon 3. So it wasn't a coincidence. Okay.
What about 9, sir? It was the value of Tn.
I simplified this.
It was A.
No, the a value is not 9. The a value was minus 6. Remember, I used minus 6
Okay,
and
yeah,
r
yeah,
minus 2 over
yeah.
3. I simplified this down and it turned out to be this one working.
Sure, yes.